Can anybody else also record? Akash? Just a second. Akash is not able to join. Hello? Hi. Actually, some people have not received the email, so I'm sending the email again the to everyone, so that. So I'm sorry for this. This won't happen tomorrow mm, because this is just because tomorrow the link is going to be the same. All right. So I'm going to send it to everyone. Okay. So the webinar link. Okay, just give me a second. All right. All right, just give me one more second. I'm just finishing sending the email. And all right. All right. Great. So, yeah, tomorrow means the next Saturday. All right. I'm hoping that everybody would be able to join now. Let me see if Anil is able to join. Okay, great. All right, so also I would like to make somebody else also organizer. Akash, can I make you the co-organizer so that you can also record the session? You can communicate by typing through the chat window. So I'm making you the organizer. So you will have to start recording. Okay, have you started the recording, Akash? All right. All right. So everybody is able to see their CloudX Lab details on the course page. Is there anybody who is not able to see? All right. So as a quick overview, you could log in into Ambari, Hue, or Web Console. All right. Logging into Ambari and Hue will be something very quick and simple. But since you may not have used this kind of interface like that of console, there might be a little bit of a problem. Okay, so you just copy paste the login, go to no big data, copy to the clipboard the password, and paste the password. So that way you get the login and the password. That way you can log in into the system. When you type the password, you may not see any echo, neither the asterisk, but it's typing. That's the way in Unix the password prompt works. Even if you type, nothing will show up. Okay, so you can log in into the console. So is everybody able to log in into console, Hue, and Ambari? Yes, Anuj, Akash, good, good Anuj, good Akash, good Tracy. All right, so that means okay, Josephine. So what we have to do is we have to log in into console and try logging into Ambari and Hue. So let's say open web console, copy paste your login into the login, and then copy the password, enter the password. Okay, question from Akshata is how do you get the console? Just click on the web console link. It's not working, Akshata, for you? Okay, can you copy paste your email so that I can just take a look? Never mind. So, what in here do you see something called web console? Hello, I think somebody had joined. Yes. All right. I think everybody is able to log in except Akshata. Are you able to? Okay. For Robert, Robert is able to log in into Hue, Ambari, and console. Akshata, are you able to log in into Ambari, Hue, and web console? Good. Narottam is also good. Okay, let me just take a look at Akshata's screen. I'm hoping that everybody would be okay. So Akshata, I'm making you the presenter for some time. Okay, that's good. You are able to log in into Ambari. That's good. Now let's take a look at Hue. Okay, you can hide the password, please. Good, good. So you are able to successfully log in into Hue. Now next is console. You can click on the hide. Copy password, copy to clipboard. That's good. So you are able to successfully log in into console, Hue, and Ambari. Great, great. All right. So Anu's question is, let me answer Anu's question. Okay. Josephine, are you able to do it, or you want me to make you the presenter for a minute? Okay. So timeout of after 60 seconds, if you don't do any activity on the console, then you will get a timeout after. Okay. Let me just Josephine, I'm making you the instructor. Sorry, not instructor. I'm making you the presenter. I think that'll be it. So everybody is able to log in into their Ambari, Hue, and console. Let me take a look at Josephine's screen. Probably that will also solve other people's problem. And I'm making you the presenter. I think it'll take some time for you. All right. Is there anyone else who is not able to log in? Because this is very important because we want all of our students to have access to CloudX Lab so that they can practice as we talk. All right, great. Looks like, yeah. Okay, okay. All right. Before we move forward to today's theory part, do you have any questions for me? Yes, Anand Kumar. Console will say timeout because yeah, you can close it or refresh it. Just refresh the screen and copy paste the password and log in. Anil is saying that I couldn't log in. I tried to reset the credentials. Could you check your spam folder? Because some of our emails are going into spam. I don't understand why. So could you just check the spam folder? Okay. I'm saying talking to Anil because Anil is not hasn't got any login or password. All right. So okay. So yeah, it went into spam. All right. Can you just mark it not in spam so that maybe yes, Josephine, we are able to see your screen. All right. So can you open No Big Data and My Courses? Yes. After login, console will prompt like this. That's correct. You can you can run your first Unix command, say ls, and you can see the list of files. Okay, here you can either refresh the window and log in password again. Um, I think Control C is not working, so you can right click and paste. Copy to clipboard, enter. Because here the password will not show, therefore you will have to assume that you have typed and press enter. Copy paste the login. Yeah, that's right. In the similar way, copy paste the password as well. There's a copy to clipboard button. You can use that. Enter. Just paste it and enter. It should work. All right. That's login. You're pasting login. Press enter again. Just refresh it. Yeah, copy paste the login, please. Oh, actually, there is a white space that you're copying. That's the reason. There is a white space in the login that you're copying. You see, there is a white space in the beginning of the login before K. Therefore, that's the reason it is saying login incorrect. You can press backspace and correct it. The mouse will not work. You will, or you can just press. Okay. Again, I think there is a space in the login. Copy to clipboard and use that. Yeah, this time is correct. Yeah, good. Copy to clipboard. All right. So, okay, let's take a look at it again. Let me try to log in into your account and then check. Okay. All right. Uh, okay. So, okay, let me do it after the class. Will that be all right? Yeah, that's right, Divan. Let's deal with it maybe at a later. That's okay. because mostly these problems, maybe the login is incorrect in real. Let's just check it. Okay, so okay, can you just copy paste your login, only the login, into the chat? I will just tell to somebody from my class, somebody from my support team, to take a look at your account. Just give me your email ID in the chat. That'll be good. That'll be good. All right. No worries. By the time we discuss, somebody will take a look at it. All right. So we will continue with today's discussion. All right. No, there was no need of pasting the password. All right. Great. So before we start our the usual class, do you have any questions for me? Okay, so again, there are some students who are not able to log in. These issues are only in the first class. Later on, because these are basically issues related to getting started. Hi, actually, there were one or two more students who are not able to log in. Extremely sorry for this. Nothing to worry. And it's just that in the beginning of the class, because this is the true beginning of the class, because yesterday class was kind of open for all. Therefore, this is probably the beginning of the class, and that's the reason there are minor teething issues. Okay. All right, everyone. Okay. Okay, very good question from Robert. So Robert's question is, when I type X clock, it says cannot display. So, all right. So let me explain other ways of logging in into the cloud. Yes, Narottam. We will take these issues at the end. The only thing is that there are few students who were not able to log in. Join even the class. Therefore, I had to take the calls. Okay, so that happens generally in this class, as in the second class, not in the first class, or not in any other classes. So nothing to worry. And generally, this way, the way we are displaying other people's screen, uh, all others are able to fix their issues. So we don't have to handhold everyone. Okay. So never mind. So in case you are not able to log in or get started, just send me an email with one-on-one request that I'm not able to understand, and whatever is the issue. Then what we can do is we can schedule a one-on-one with you and get you started with all of these technology stacks. Great. Now we have a very good question from Robert. Before answering Robert's question, let me take a step back and try to explain other ways of logging into the console. So Josephine's question is for Ambari, what are the username and password? It's the same username and password as mentioned on the UI. All right. Now, so before we came up with this web-based console, how did people log in into the server? For Windows, people used something called putty, right? They'll first download the putty, then they will log in into the server. Okay, using the putty, they can actually, specify the host name. For you, the host name is going to be where is that screenshot? Okay, all right. So with the getting started with putty. So on Windows, since it doesn't have it okay, I'm just looking for. Oh, it doesn't have the screenshots. Will it have the screenshots? No, it doesn't have. Never mind. So people use something called putty on Windows, and if you are on Mac or say uh, Linux, you can go to terminal. If you search in Spotlight, you can find terminal on Mac. Similarly, on Windows, on Linux, you can find the terminal in your accessories. Here, you can say SSH. This is my console, which is basically my desktop or laptop. I'm saying SSH, and I'll say E dot. Here, what will I put? I'll put this login, right? And say at, and the web console's IP address, which is e.cloudxlab, e.cloudxlab. For some of you, instead of e.cloudxlab, it might be f.cloudxlab. Okay, so here I can say yes, and it'll ask me for password, and I'll enter password. So here it's the same console what we get here in the browser. Without installing anything, you can get it from the browser. If you don't like the browser, what you can do is you can log in from the terminal. Okay, now the next question which I'm trying to answer here is, sometimes you want to get the access to the graphics of e.cloudxlab. What does this console represent? Console represent a command prompt on which if you type any command, it is going to get executed on this server called e.cloudxlab. If I say pwd, this is my home directory on this server, and if I say free.h, it shows how much memory is free on this particular machine called e.cloudxlab. Okay, so effectively, this is as if you have logged in, as if you are sitting on the same machine. Okay, from the Windows command you cannot do it because SSH is not available. You will have to download putty. Okay, you can download putty from here and then get started. Okay, on putty you will have to provide the login and the host name. Take a look at the documentation provided in this. It's called installation instructions, and there is instruction on the cluster. This is not required for these classes, but if you are interested in installing Hadoop on your cluster, you can use this documentation. Okay, this is external documentation pointing to Hortonworks one. And this installation documentation talks about two things. One, logging into CloudX Lab, and second, how will you run the virtual machine? This is the virtual machine. How will you run virtual machine? This is a little longer way. Basically, you will download a virtual machine and you will run it. But I would not recommend it. I would not recommend it. Okay, all right. While this one is recommended. All right. Good. So basically, there are two ways to use Hadoop. One, using our CloudX Lab. Second, by downloading the virtual machine. This is the traditional way and is not very effective because there are many hurdles to starting with virtual machine. The other downside of VirtualBox is that you basically don't get an experience of using a cluster. Okay, because all of these tools which we are going to talk about in this course are cluster oriented. Therefore, it's very important to learn on cluster. If you are on Windows, you can download putty, and on the putty you will have to provide your login at e.cloudxlab.com and this port. All right, rest you'll remain same. You put your login at e.cloudxlab and then this port. Okay, so in this box, you will say whatever is your login and then at e.cloudxlab or f.cloudxlab. Okay, this document is located in the session 1 of No Big Data My Courses. Okay, when you go into My Courses, you will see one of the courses called Big Data and Hadoop, 4th June. Under that session 1, you will find this. All right, so I hope everybody is with me on the same page. Great. So go through these documentation and if time permits, go through the quiz as well. Okay, so now everybody is with me with respect to the logging in into LMS and CloudX Lab. Okay, all right. So today we are going to discuss HDFS. All right, today we are going to discuss HDFS and we'll do a very brief recap. All right, so yesterday we discussed why a single computer is not sufficient to do the computation for many reasons. Sometimes the RAM, sometimes the CPU, sometimes the hard disk, the speed, and the size, and sometimes the network is the bottleneck, and therefore you need to use distributed tools such as Hadoop. Hadoop contains all these components. The most important component of Hadoop is HDFS, which is Hadoop Distributed File System. On top of Hadoop, there is a Yarn. Yarn is yet another resource negotiator. It is kind of an operating system on on top of many machines, meaning we can ask this operating system to execute our program in the way we want. Similarly, there are other tools such as MapReduce and Spark, which are compute engines which convert our logic, which we program against, and they execute our logic via yarn. And then there are higher level tools like Hive and Flume and Hive, Pig, Mahoth, Flume, and Oozy. Hive and Pig are used for analytics, and Mahoth is used for machine learning, while Flume is used for importing unstructured data, and Scoop is used for importing data from the structured sources, meaning the traditional databases. All right. So this is the ecosystem. This is the ecosystem which we are going to talk about slowly as we go one step forward. There is one tool which is not mentioned here, uh, and I'm not talked about one tool. So one is HBase. HBase is a NoSQL database, which is basically for storing data in the form of rows and columns. As opposed to HDFS, HDFS is used for storing data in the form of big files. Now, HBase is used for storing billions of rows and millions of columns. And the there's one component which we have not discussed here is Zookeeper. So Zookeeper helps us in managing various tools. We'll go into the details of every component as discussed here. All right. Now, before getting into the details of HDFS, let's discuss why do we need HDFS in first place. Okay, so here is a problem to all of you. Okay, it's something which you must have tried if you are into little bit IT and you are watching movies and storing data on the hard disk. You must have thought about it and you must have tried to solve it earlier. So question to all of you is, let us say you have to store 100 terabyte of data. How would you do that? How would you build such kind of storage capacity? Imagine that you are living in a hostel or living in a big society whereby you want to build your own storage of movies. How would you do that? And your estimate is that in 100 terabyte of storage, you can store almost every movie. So how would you build such kind of system where which will contain all the movies? Yes. Mm-hmm. Balvinder says upload it to cloud and backup tapes. Interesting, interesting. But if you upload it to cloud, then basically that's the problem we are trying to solve. You are just handing over your question to somebody else. And backup tapes, yes, but there are complications with backup tapes. We'll talk about those kind of things. Ravinder says that store onto into the disk, but we don't have a 100 terabyte disk. Anil, feel free to answer to all because your answer is very good. Okay, can you answer it again to everyone? Very good, very great set of answers, I must say. All right, let me just put my mouse. Okay, great set of answers. Kanan says that we can mm, so mainframe database to store. We can use mainframe database to store large data. That's good. And Anil says network attached storage. Pavan says store it in multiple disks. If there are multiple files, brilliant. Compress the data. That's good. But even after, let's assume, Robert, that while after compression of the data, it is still say 90 terabyte of data. Then Good, Samip. Balvinder says, how about a RAID? Ravinder says, how about a SanDisk? Very good. Akash says, equally distributed data into 10 hard disk of 10 TB each. Good, good. Wow, good. Thank you, Tracy. That's a very great set of answers. Any other? Yeah, very great set of answers. I think I got really good answers. Anybody else? Feel free to come up with your ideas because you will find that most of the ideas have turned into a large product. So, sometimes in the last session or before, somebody came up with the idea that why can't we build a torrent-like system? And that's a good answer. Narottam says that create one mount point and store data in multiple disks with equally distributed symmetrically. Brilliant, Narottam. We will discuss this answer in detail. Subham says store data in different disks and mount at the same disk on one server. Brilliant. Now let's get into. So the common answer from all is that let's have many hard disks, attach them in some way, and then access them. Okay. So we generally call it NAS or SAN. NAS is network attached storage, while SAN is storage area network. Okay, so to store this kind of large data, traditionally what we have built is either a network attached storage or a storage area network. Okay, if you have if you have say hundreds of 1 terabyte hard disk, so what you do is you connect these hundreds of drives into many computers and connect those computers in the network, and afterwards when you have brought all these networks all these computers in the network, you mount these each hard disk as a folder. So the way you will at the end of day while using these drives, what you will see is that there is some folder and there are say 100 subfolders. Now question is there any problem with this kind of architecture? Okay, is there a problem with this kind of architecture? Ajay's answer is there is no failover. Brilliant. Good, Pavan. Any other? There are many more problems with this architecture. Some of you have already used it. Anu says that speed with which we access the data. Brilliant, brilliant. Pavan says synchronizing read. Brilliant. Good. Akash. Network speed definitely will become the constraint. Good. Now, Rawl says data consistency, cost, good. What if all the people want the same data at the same time? Just brilliant. Yes. Availability during the load. Brilliant. Any other problem do you see? Great. Yes, that's right. So all the things which you have mentioned are actually correct. Yes, there is no fault tolerance, there is network congestion, there is availability problem, as in if all the people want to watch the same movie on the Independence Day, then it's going to be difficult. Very great, very great. All right. So I have summarized your answers in a way. One, when you build this kind of network where there are many computers attached to each other in a network, and then mounted these hard disks at the central point, there are challenges associated. And this was the traditional way. This was actually the way we had built our network at DE Shaw. Even that was a traditional way, and the that was the only way we actually built the systems. Now, the biggest challenge is what happens when one computer dies. You might argue at this point that we could put one hard disk along with another hard disk. We could pair each hard disk with another backup. If we have 100 hard disks, we buy 100 more hard disks and put the backup. The question is that it does help you in saving from the disaster when hard disk fails. So it saves you from the disaster of hard disk failure, but it does not save you from the disasters such as a computer burns down. It does not save you from the disaster that a computer got disconnected. I've seen the cases where in the data centers the mice bite the rats might bite your network cable. So in all these circumstances, all right, so the failover and backups are not really that great. A next question from Anil is storage capacity. If a disk is run out of space, the whole operation fails. Brilliant, brilliant. Here at this point, you might argue that we could put the data into some other folder, right? But then again, that's a constraint with respect to the data design. Tracy says that how would you split shard the data for efficient searching and retrieval? Yes, that's another problem. Akshata's question is, what does it mean by a failover? Let me explain. So one thing is called backup, meaning your in case your data get lost, there is a copy of the same data available in your tape drive, right? That you can manually go and pick it up and bring it to the life, which means there is no permanent loss, but there is a loss of availability. Okay, so failover means in case one computer fails, there is no other computer to take care of that responsibility. That's called lack of failover. Failover means if a computer fails, the when one system fails, the other system takes over. That's called failover. So there is no failover and backups in the system. How would you distribute the data uniformly? That's exactly the question from Tracy. That in case let's say we design a scheme, we say that let's store all the movies alphabetically, and all the movies starting with A go into first hard disk, B going into second hard disk, and so on. Now in this kind of architecture, there are many movies that start with A and the, right? And there are very few movies that start with Q, or say the very few movies that start with a letter like a letter like Z, right? Or for that matter, V, U, and W. So question is that while some machines will be overloaded, other machines will be comparatively free. So you can't distribute the data so easily uniformly. Next is this the best value for money? Is this the best use of resources? We might have hundreds of smaller hard disks available in the network, and if we try to put those smaller hard disks into this network, there'll be too many nodes and distribution headaches will go skyrocketing, skyrocketing high. As in, if your company might be having the smaller hard disk already, can't we use them? We can't, because for if we try to use those, we may again get into the problems of distributing data uniformly. Or if we have 1 gigabyte of say we have 10 gigabyte of hard disk, but we want to store 70 gigabyte Blu-ray movie, how could we do that? So in this kind of architecture, it does not support using a smaller hard disk without hurdles. Next is this particular point you guys have already pointed out, increasing availability. What does it mean? Increasing accessibility or availability, what does it mean? Let us say today is Independence Day and everybody wants to watch a particular movie related to the independence. That is very common. Now, because of that, what would happen is a particular computer which contains a particular machine which contains that movie, that will go under a huge stress because these hard disks, if they are not solid state hard drives, they are physical hard disks. If these hard disks are kind of because these hard disks are physical material, they have a header just like in your tape recorder. You have to rotate the tape, right? The cassette contains a ribbon kind of thing that rotates. Instead of that, in case of hard disk, is the header that moves, not the header that moves, but again the hard disk rotates. So it's a physical movement involved. So every time you do the seek, every time you try to read the data, the header physically moves, and there is only a single header. Therefore, at one point of time, only one user can actually read. So essentially, hard disk is the bottleneck in the game, right? For the accessibility. Next question is scaling out. Today, we are designing the system for 100 terabyte. Tomorrow, let's say we need the system for 125. Now, the moment we bring in 25 more hard disk, redistribution and everything would be a mammoth task, would be an uphill task. So these are the problems. So these are the problems associated with traditional way. The question from Pavan is, there should be some management software tool to manage chunks, and that's where we come to HDFS. So solution to these problems is HDFS. We will see how efficiently HDFS solves all these problems. Okay, is everybody with me so far? Am I able to justify the value, or am I able to point out the problems associated with the traditional way of storing data? Yes? Great, great, great. All right. Now, let's get into the discussion of HDFS. So, first and foremost, HDFS is made up of many services. And those services are basically two kinds. One is name node service, and other is data node service. Why I'm calling them service? Because what are these things? These are the network services. So when I say somebody, this computer is a network, this computer is a web server, this computer is a mail server, this computer is, say, uh, something called database server. What does it mean from the point of view of an operating system? It means that on this computer there is a process running and listening on a network port. Okay, port is like a window on which somebody stands, and the people who are want to access or talk to the system, they go to that window and talk. So when I say that there is a computer on which there is a web server running, and so what do I mean is there is this computer on which there is a program which is running continuously and waiting on a port. And this port in case of web server is 80. There is a number for every kind of ports. Although you can run any kind of service on any port, but there are few designated ports which are, the common sense people, uh, think of those ports as standard. So for web server it's 80. For HTTPS it's what is that? I completely forgot. So it is 443. And for say database MySQL it's 3306 and so on. Similarly for database there is a process running on the machine which is waiting for the orders from the people and listening on a particular port. You can always think of port as if there is a receptionist waiting on a window and people can go onto that window and talk to the receptionist and get their questions answered. Similarly, on one machine we install a process called name node, and on every other machines we install the other processes called data node. Data node is also listening on a port, and name node is also listening on a port. If people want to talk to name node, they will talk to go to a particular port, and if they want to talk to the data nodes, they can go to those machines and talk to them on those particular port. And how do you talk to these machines? You can either use program like NC. Okay, you can use a program like ANSI, or you can use a program like SSH. I could just quickly show you that no big data is running on 443, right? So I could say ANSI no big data.com and 443. So the server is running on the port 443. All right, so I'm connected to the server. It's a, although because I have typed it wrongly, I've not given the correct input. It's saying that it's a bad request. I could say get. This is the way browser is talking to a web server. Okay, so all right, I'm not encrypting data, so it's giving the bad request. All right, so this way you can talk to any port of your choice. Okay, I could talk to 25 port on this server, and I could talk to say I could talk to any machine using NC. NC is a tool installed on Mac by default, but there are other tools like Putty, or there are other tools like SSH using which you can talk to any service at any port. All right, thank you, Anil and Pavan. All right, great. So here we go. Now, that was a brief description of what is a service or what is a port. All right. So, on so HDFS is installed on many machines, and what do we mean by on some machines we install data node, and on one machine we install admin node or name node. Now, this admin node or name node is somebody who is keeping the track of what is where. Remember, in our last design, what we had done was we were trying to keep a track of by using a kind of indexing, right? All the movies starting with A went to this machine. All the movies starting with B went to some other machine. That kind of model. Here, this admin node or name node is keeping track of all the files in various data nodes. Okay, while the data nodes is the actual worker. Data node is the actual storage that store the actual content of the data. So the information of how many directories are there, which directories is in which folder, and what are the various file name, this information is called metadata, right? And what is inside a file, that's the actual data of the file. So that inside of the file, when you open some file in a notepad, whatever is inside that file, that data goes into data nodes, and the information like name of the file, folder name, size of the file, and last modified, the permissioning, and everything, that's called metadata, and this metadata is stored in name node. And And this metadata is kept in the memory. Memory, when I say, is RAM, random access memory, and this random access memory is extremely fast. Although there is a backup of RAM, but a copy is kept in the memory. So there are few questions that would be coming to your mind right now. One is there a backup of name node? Or the other question that would be coming is that what if memory fills in? We will answer these questions slowly, but that doesn't mean you don't ask those questions. Anu's question is name node similar to fat table for Windows file system? Brilliant. Yes. Fat table is file allocation table. When you store data in your local machine, the data is stored in the form of in a format called FAT32 or NTFS, and there are a few more file systems like HFS. Those are native file systems, and these file systems store data in the round tracks of the hard disk, right? And on the beginning of the those round tracks, on the beginning there is a small arc dedicated for this information, that which file is at what angle, at what radius. So because this round one, every location has got an address, and this information that which file at is what address is kept in that initial bytes, and that's called file allocation table. So this analogy is brilliant. Thank you, Anuj, for that. Yes. Nand Kumar's question is this architecture similar to Teradata? This architecture is different from Teradata. I need to look at Teradata's architecture. As far as I know, that Teradata is not built for really huge data like in petabytes, but this one is built for petabytes. I'll have to take a look before I comment. All right. A brilliant question from Anil. Can a machine be both name node and data node? Yes. In our case, the host called a.cloudxlab is both name node and data node. I'll show you this part because a machine can have two services if they both the services listen to different ports, meaning different listen to different uh, portal. So if in an office, if there are two people who are working, whose job is to listen for the customers, they can sit on different windows, right? Similarly, here, name node and data node can run on the same machine as we are running on CloudXLab. Good, very good. Narottam's question is, if name node is getting multiple requests to access the metadata, how it manages? It keeps a queue. It makes sure the data is 100% consistent. No two persons modify the same data at the same time. Okay, Ajay's question is, what are these services run on name node and data node? If I want to check it on CloudX Lab through Web Console, so you can go and say what's it called, PS3 or PS. You can check it. Most of these, both of them are Java processes, because name node and data node, the source code of both is written in Java. So when you launch data node on name node, both are essentially launching a small JVM and listening on a particular port. All right. Now, very interesting question from Akash. Can we directly access data node without help of name node? The quick answer is no. Although, since data node is actually storing data in the local file system, in the native file system. Okay? Therefore, you can definitely go into that particular data folder and look around. but that's not something HDFS would like it. All right, I'll show you where does it store the data. Okay, so I can relate this idea with any data warehouse that typically ranges terabytes in size, and we have BI tools, reporting tools to identify trends, etc. Yes. So the design is actually inspired by many similar ideas, Balvinder, but it's not going to replace, it's just going to cater to a different kind of scenarios. Nankumar's question is, if the name node is down, then is it the whole system down? Yes, kind of. So, but therefore we have designs like backup name node and standby. We will talk about it soon. All right. So looks like everybody's ready to move to the next level. Now, the next complication that arises, if you remember our problems of distributedness and making it equal, right? So for that, what HDFS did cleverly was it broke the files into small blocks. While storing the data, instead of storing the full file in one machine, it cut it into pieces and parallelly stored the data onto many node, and every so the file is splitted into a chunk of 128 MB each. Earlier it was 64 MB, but now people have chosen to use 128 MB. In case of CloudX Lab, we are using 128 MB. So while storing a file, the file is cut into the chunks each of size 128 MB. The last chunk might be smaller than 128 MB. Why? Because not every file size could be divisible by 128. So when you're dividing a file into 128 MB each, some of the blocks might be smaller. So these chunks are called blocks. We'll be using the blocks to represent this. Now, this cutting of the blocks is very ruthless. Why? Because it doesn't care whether your file is movie, music, plain text, or Excel file. It'll if cut the data into each block of 128 MB. But that doesn't mean that even though the last block is smaller than 128, it won't take. So the last block would generally be smaller than 128 MB. It doesn't mean that it will take still 128 MB size. It doesn't. It will take only the the remaining part. Okay. So if you have 100, so data nodes contain these blocks in them. And these blocks are, of course, stored using the local file system running on the data node. Because data node is also a computer like a Windows or a machine like Linux. Generally, these machines are Linux, and even on Azure, the machines are generally Linux, but now they are moving to Windows. So the data node is a computer which is running some kind of operating system, and on the operating system there will be a file system, and when data gets stored on data node in the form of blocks, it actually creates a file of that much size. All right, I'll show you that these files are actually created in a folder in the local machine at slash data. All right, so while storing data, the metadata went to name node, and the file was cut into blocks and stored on data node. These cutting of the data happens by the HDFS client. You don't have to cut by yourself. There is a client that can do it for you, but if you want a custom way of storage, you can cut it by yourself if you can talk to name node. So the main reason why we cut a file into these blocks is so that the data can be divided equally. Second, it optimizes the data transfer. Let's say you are trying to store a 1 gigabyte file, so it'll have 8 pieces. If you have 8 computers, the file can be written to 8 computers parallelly and very quickly. Second, when you are doing the rebalancing, some of the nodes are getting more data. It's easier to do the rebalancing if the data is small, if the transfer units are smaller. Now, and similarly, when we are accessing data, we can read from multiple machines in parallel and then access the data. So that solves our problem of network of reading data from many sources. Okay, so this is one. Good. Is everybody with me on this so far? Great. Next is every data block has got multiple copies. Every data block has got multiple copies. What does it mean? It means that it's going to waste twice amount of data storage. If you want to store 1 GB of file, there will be 8 blocks, and every one of these 8 blocks is going to have co- three copies of it, meaning it's going to consume 3 GB of storage. Now, no two copies of a block are kept on the same data node. No two copies of a block is kept on the same machine. Why? Because in case that node goes down, then both the copies will go down, and there is no, the purpose of having the copies of a block is defeated. Because the purpose of having copies of a block is to have failover, immediate failover, because in case one machine goes down, whatever is lost will be regenerated by the use of other nodes which contain the same data. And therefore this backup mechanism is quite powerful. All right, so for a 1 GB file, there will be 24 blocks, 8 original and 16 more backup copies of the same every block. Right? There will be 8 blocks of 1 GB data, and each of these blocks will have total 3 copies, and therefore it's quite robust system. In case one machine goes down, immediately name node would be informed that this machine is down, so don't send a request to this machine, instead send to somebody else. Yeah, as soon as the it is noted that a machine is down, at the same time these two machines are informed to start copying data that is lost because of a machine, because of the one machine down. Okay, so a backup is retrieved immediately and automatically, and this keeps happening all the time. I could show you that we could just shut down one data node and still will be able to access the data. Now you might ask that why do we have 3 copies, why not 4, why not 2? This is the default behavior. You can change it per file basis. You can also set the default, you can also configure the default replica factor. If you trust your file system really well, if you are using SSD instead of normal hard drive, you could choose to have only 2 copies. But I would not recommend replication factor of 2. Okay? So you can change this replication factor for every file, as well as you can also recursively set the all the files replication factor inside a folder, as well as you could configure the default replication factor. Now, if your data is very precious, you keep more replication factor. If your data is not too too important, you have alternate copy somewhere else, or you can download this data from somewhere else, then you are free to keep a single copy of that data. All right, but I would strongly recommend to have multiple replication, because as we will go ahead, you will notice that when multiple people are trying to access this data, it becomes easier if there are more copies of the data in the network. The availability issue is very well solved. Good. A question from Ajay: does it mean generally name node should have fatter network pipe? Not necessarily. I'll answer this question in a minute. Because so you can't have a individual you can't control the network pipe, right? If there's a big network pipe for name node, it would be same for all others. Next question is, if data node fails, the lost block will copy to other nodes before data node fails or after the so as soon as data node fails and it is noted that name node has not received any heartbeat, so all these data nodes keep on sending the heartbeats to name node. In case name node does not receive any heartbeat from any of the data nodes, name node marks those data nodes as dead and immediately orders other data node to start regenerating the replication factor, because of a loss of data node we have lost the blocks, and essentially all the files whose blocks are lost, their promised replication factor has come down. To regenerate that, the same blocks need to be copied to some other machine to to bring up the replication factor to the one which is promised to the user. Was I able to answer your question, Kanan? Okay, good. Next is Narottam's question. Can we? No, there is one more question before that. Okay, now can we see the metadata files slash replication factor, block number, data number on name node and file size once entered into HDFS through console? Yes, I will show you that as we go forward. There is a command called HDFS. Using that, you can do that. And similarly, there is another command called Hadoop space fs. Using that, you can change the replication factor. But you can only change the replication factor of the file that you own. Anil's question is, should the replicated block be under same name node? If there are multiple name nodes in this, there will not be multiple name nodes, there'll be a single name node. Okay, we'll go into a particular design in which there are more than one name node, but that's too rare. We will talk about that particular design. Akash says, what about name node's replication factor? We'll talk about it. Name node has something called standby name node. In case this name node goes down, there is another name node which will take the failover. Okay, so all right. Next is, this is something which we carry in our head. This is something in which we build build the picture, but this is not the case. What does this diagram show? This diagram shows that the user will come to name node. Name node will bring the data from data node and hand over the data on a silver platter to the end user. No, this is not how name node behaves. This is not how HDFS behaves. Why? Because in this case, name node is the bottleneck. As Anil has pointed out earlier, I think Ajay has pointed out earlier, saying that maybe we would need a bigger network pipe. If this was the architecture, then we would need humongously big network pipe in this case. Because this is a typical bottleneck. Here, the total amount of transfer that can happen is equal to the network pipe of name node, but that's not true. This is not how it behaves. The way it behaves is this: Before the user, there is a client driver, just like you have a JDBC driver or you have some other network driver for talking to things. So this client driver, so user will ask the client driver, get me a particular file. Now this client driver will go to the name node and talk to the name node, and name node will tell that, hey, you want this file? You go to these data nodes and get the file from there. Don't ask me for the data. I keep only the metadata. Okay, so client driver gathers the metadata from name node and then brings the data from the actual data node. So essentially, the client driver is responsible for doing all the magic of talking to name node, talking to data node, bringing the data. Okay. So actual transfer, so name node is not bottlenecked by the actual transfer. Okay. And while client driver is reading the data, name node makes a note of it that somebody is reading the data from that particular data node. And once data node finishes reading of that data, it informs name node that, hey, this particular read is finished, so you can mark me free. Okay, and that's how the whole communication happens. Okay, was I able to answer your question, Ajay? All right, good, good. So this is how the behavior of name node is. And again, it also answers another question. When for the first time a user sees, oh, you have to cut the file into blocks and store it at these places, people get scared. People start thinking that they have to read byte by byte and talk to this file system and so on. So all of this complexity is hidden from you by this client driver. You only have to talk to it as if it's a normal file system. You have to ask client driver saying mkdir xyz. It will create a directory and it'll do all the complications, right? Now, a question to all of you. Question to all of you. I think it would be coming up by itself. All right. Let me ask a question at this point because you can all understand now. Okay. Question is, all right, here. If we ask client driver mkdir x, right, it would talk to A, both both name node and data node, B, only name node, C, only data node, D, error. Brilliant. Yes. It's going to talk to only the name node. Brilliant. So this is the first class who has answered this question correctly. Okay. So when I create a directory, I'm essentially creating a metadata. Directory is not real data. Real data is what is inside the boundaries of a file. Therefore, therefore, when I say make directory, okay, and next question is question number 2. What about what about ls? Yes. Pawan says name node. When I say ls, what is it going to do? Ls is list the files. Is it going to talk to both only name node, only data node, or error? Nandkumar says B. Okay. Akash says B. Anuj says B. Brilliant. Brilliant. So yes, in case of ls, what are we saying? Give me the metadata. I'm not asking for what is there inside the file, right? So it's going to only ask for talk to name node. Now, question number 3 is cat my file. What does it mean by cat my file? If there is a file called my file, print the data what is inside my file. Is it going to talk to both only name node, data node, and error? Correct. In case of cat file, it's going to talk to A, which is both. All right. First, it is good. When I say cat my file, what's going to do is first going to go to the driver, this driver here, this client driver. When I said, please give me the data of my file or print the data on my of my file to me, client driver is going to go to name node and say, do you have this data called my file? And name node will say yes, I have 15 blocks of it, three which are three copies of 5 blocks each, and these are the data nodes and these are the IDs of every block. Why don't you go and talk to data node directly? And this client driver will go to each data node and do the operation. Okay, great. So this is the typical structure. All right, we'll continue the discussion further after the break. So let's break for 10 minutes and back by 9:46 p.m. IST. All right, everyone, I'm back. So, should we start now? Great. All right. So, okay, there are two questions that need to be answered. Okay. One question is, since name node and data nodes are services on machines, good. Can we have hybrid system name node on Windows and data node on Linux? Brilliant question. Theoretically, yes, because it's in Java and Java can run anywhere, and these are network processes, they have the same protocol, they should be able to communicate. But in reality, for whatever reason, whatever mysterious reason, as of now, it's not supported. I've actually tried using Ambari, whereby one computer was having, say, Red Hat, another was having CentOS, and it gave an error saying that both the systems are not having the same operating system and same architecture. So all the machines that are part of name node and data node should have exactly same operating system. Same operating system and same architecture. Okay, whether 32-bit or 64-bit and so on. All right, good. Next question is, which process determines which copy of the file should be accessed? The quick answer is name node. Okay, and a name node is generally telling the driver client that these are the copies that are mainly available and are closer to you, and you can talk to these name nodes, these nodes. And driver node also has can choose, no, I don't want this one, I want specifically this particular machine. Okay, so client driver, you can write your own API which can disobey node with respect to who gets the preferential treatment. All right. Next is the HDFS architecture reveal state. We are so this diagram looks little bit more complicated. It has got five data nodes, one name node. Name node is containing the metadata. Metadata means the name of the file along with the folder name. Replicas as in requested replicas. This particular file has got three copies, as in a guarantee of three replicas, and these are the data nodes containing various kinds of blocks. Now when the client comes, it can read the data from any of the data nodes after talking to name node. Okay, so client can talk to name node and then read the data from these data node. Similarly, while writing the data, client can first talk to name node and then go to individually data node and then write the data there. While creating a file, first it will inform name node saying, hey, I want to create this particular file which contains this much data. Name node says, okay, I have noted down in my temporary folder saying you want to create this particular file. Please go and create talk to these particular data nodes and tell them that you are here to create these blocks and save it. And once you are done, please come back to me and I will mark your changes as committed. Okay, so that's how it works. So name node starts kind of a transaction, and then client goes to individual node, finishes the writing of the blocks, and then once it has done, it goes in name node and commit the transaction, and that's how the file writing process works. Okay, now the important part here is Akshata, you can ask this question to everyone because that's very important, so everybody can also think on the same lines. Question from It's a good question. Question from Akshata is, after client finishes writing, who takes care of replication? Replication is started by name node, but actually done by the data nodes. So you can see that the line between the two nodes, the replication is happening between the machines. So client writes a copy here, and the replication starts happening amongst node. But this decision, which nodes would keep which copy, would come from name node saying, okay, fine, you have kept the data. Now please make the copies to the data nodes as well. So the first copy of the data remains on the same node, and the other two copies are on other two nodes. All right. So replication is not handled by the client. It is handled amongst the data nodes. All right. Good questions. All right. So that's how it works. So Akshata's question is, does replication happen in parallel to writing? The quick answer is no. Once you finish writing the data, once you finish writing the block, then block start replicating. Okay. So when you finish writing a particular block and you commit a file, then the replication starts and the blocks are replicated. All right. Okay. Great. So let your chat go to everybody. That's okay. On what basis name node decides which data node to keep the data? Very good question. So Nand Kumar's question is, on what basis does the name node decide where to keep the data? Okay, the main criteria is to have the equally used data nodes. So some data nodes could have smaller disk, other data nodes could have bigger disk. Based on that, name node tries to put the copies accordingly. Okay, so the first copy of the data is always kept on the node on which the transaction has started. Okay, so let's say you're standing on this data node, you are sitting on this data node, and you are trying to talk to HDFS, meaning name node, and trying to store a file. So the first copies of all the files, because data node is also a computer, right? So you are logged in like e.cloudxlab. That's actually a data node. So you are on e.cloudxlab and you are trying to create a file, meaning you're copying a file from local, meaning e.cloudxlab. From e.cloudxlab, local file system, you want to copy it to HDFS. So what would happen is the first copy would actually be stored on the data node which is running on the same machine, and the other two replicas will be on some other machine. We'll discuss that a while later. Okay. Subham's question is, as all data is kept on HDFS system and then data is distributed to other data node, doesn't it create bottleneck on single HDFS? All data is kept on HDFS and then data is distributed to other data node. Okay, so do you mean when we create a file here, all the data would be kept here and then the replication would occur, right? So it actually, the way if the client is outside the network, it might write data to two particular parallel data nodes, and those two parallel data nodes can replicate to other three, four nodes. That means the conversation is not happening only over a single wire. There are many wires involved. Many pipes are involved in the conversation, in the transfer of the data, and therefore not a single pipe not only a single pipe is busy in all these transfers. So network is not really a bottleneck. Did I make sense to you, Subhan? Next question is from Narottam. Which takes care of communication between name node and data node and another data node? Who takes care of the communication between name node and data node and another data node? So main orders come from name node, and the communication between data node and another data node is also facilitated by name node. Akshata says, is it just the size or is there any other classification based on kind of data being written? It's not based on kind of data. There is another criteria while placing the replica, placing the replica. Okay, we'll talk about this when you're placing, when HDFS says that first copy is here and the other two copies go to somewhere else, right? So none of the decisions are taken based on the kind of data. Instead, the decisions are being, because file is opaque, file is totally opaque to HDFS. HDFS doesn't peep into what's inside the file and then take a decision. No. Okay, the decisions of where to place a copy of a file or another copy of a file are done based on how many replicas do you want, what is the topology of your network. We'll talk about something called a rack and rack containing computers, so we'll talk about it in a while. And then there are few more criterias to placing the data, how much space is left on what computer and so on. Now, there are two more questions. Very good set of questions. Keep the questions coming. Okay. One question is, will replication start instantaneously or system will wait when the utilization is minimum? As soon as a file is committed, the replication start. If it fails to execute the process, it will again try. And if it gives up, it can't handle it, then it says that the blocks are under replicated. Next question from Raul is, when a data node goes down, name node seeks help from replicated node. Yes, but since writing to the replicated node happens after original data has completed its writing, how is the missed data written to the replicated node when the original data node crashes? So in the unfortunate scenarios like this, in really unfortunate scenarios like this, you actually lose the data. Okay, so let me repeat and rephrase what I understand from Rolf's question. That let's say when a data node was going down, it went down just before a particular file got replicated. Okay, so all those blocks which went to this machine, which did not get to replicated instantaneously, those will get missed. And that particular file will be marked as corrupted in by the name node. All right. So before the replication started, system crashed, a particular system crashed, and those blocks which went to that machine are lost. Therefore, that particular file will be marked as corrupted. Okay. Following question from Anuj. Let me combine the question. Question is, will system give preference to a client or a replication process. For replication process, yes, based on how much disk space is it and network topology. All right. Now, okay. Okay, I did not get the question. Okay, let me repeat the question. Will replication start instantaneously, or system will wait for the time when utilization starts? It will actually start immediately. I don't think the replication waits for the utilization to go down, because if that happens, then the situation what Rawl is talking about becomes more and more possible. Okay. Will system give preference to a client or a replication process? Will system give preference to a client or replication process? So both, basically operating system will queue both of them together, because replication process does not require CPU resources. It basically requires network bandwidth and the hard disk. Okay. Was I able to answer your question, Anuj? A question from Tracy. What if the file hadn't been committed? Okay, if the file was not committed, the whole file will be lost. Okay, if the file was not committed and that data node has gone down, or any of the process has gone down before writing has finished, the file will be marked as deleted, or you can say discarded. Yes, Anuj. It will basically follow first in, first out, and there won't be any preferential treatment. Good. Now, this is the same anatomy of a file read. You basically first, you are an HDFS client. You talk to HDFS client. HDFS client goes to HDFS file system. There is another library, and this library goes to name node and gets the block location and goes to individual data nodes and read the data and then finish that input stream. This is how HDFS client works. And for writing, a similar thing happens. HDFS client goes to distributed file system and says, create my file, and the request goes to name node, and then name node marks it a dirty, as in the transaction has started, and then HDFS client starts writing to the data node. Data node would copy to other data nodes as the blocks write. Here the big question is that if HDFS did, any of these nodes did not confirm the right, I mean HDFS client did not confirm the right to name node, and also data node also did not confirm to name node, name node will say that name node will discard a file and will ignore, thinking that the connection has been dropped. And also HDFS client will be informed that your file has been discarded. Okay, if the connection is still active. And this HDFS client, if they want to try, they can retry again to write the same file or ignore. All right, so that was a quick overview of HDFS. I hope everybody is with me. Now, there are few more things which we want to answer. All right, one question that need to be answered is, all right. Pawan's question is, based on the right anatomy diagram, the file blocks are replicated when the block is written to the first data node, but not at the same time of the file commit. Am I right? So the diagram looks like that, but I suspect that that would be happening. I would have to, take a look at it again. Okay. I might have to take a look at it again, whether blocks are replicated before commit. Okay. I'm not sure if they're done. Ajay is saying that is there a chance for inconsistency between reads and write? No. So what happens is that all the communication of which file to write, which file to read goes through a single node called name node. Therefore, therefore it takes care of all kinds of operations happening on the same file in parallel. And therefore it's a strongly consistent system. Okay, as we will study further, what does it mean by strongly consistent, eventually consistent, and there are few more majority consistent. There are few more systems we will talk about as we go further, when we talk about the protocols involved in the replications in, say, Zookeeper, MongoDB, and say HBase. Okay, so we'll go into more details, but the name node makes the whole file system as strongly consistent. Now, because name node is trying to keep everything consistent, and therefore we have only single name node. The downside of this kind of system is the name node is kind of a bottleneck. So what happens in case name node fails? The way we have been doing traditionally with name node is that we are storing the name node's metadata on the local file system as well as network file system. This mechanism is vaguely known as secondary name node. Okay, where we keep the data of name node on two machines. Okay, name node's metadata in the memory is well structured, while in the disk it's in the form of two things. One is called namespace image, and second is called edit logs. On the file system, since writing to the file system is time consuming, what namenode does is it periodically keeps the snapshot of the whole memory of the namespace in the file system, and then as and when more and more transactions are happening on name node, it just keeps appending to the edit logs. Okay, it's like if you have lots of transactions, your accountant will keep something called journal, and you keep appending to the journal that this happened, that happened, and so on. In case, why do we keep journal? In case before before the snapshot is next snapshot is going to be taken, if there is a loss of the name node, the data will disappear, new transaction will disappear, and therefore added logs are maintained. Okay, because anything in the memory is disappears when a machine shuts down. Therefore, the changes of the name node should be kept persistent. So instead of keeping the snapshot again and again of the whole memory of name node, it periodically it periodically snapshots, and then and continuously it appends to the edit logs. Okay, so both edit logs and the namespace image are kept at both the places. So you can keep it in the network file system, but by default it's only kept on the local storage. Anu's question is, so logs are cleared once a snapshot is complete? Yes. Now, this was the previous architecture. Now, there was similar thing was implemented as secondary name node. Okay, so secondary name node started keeping the copy of namespace image and edit log. Instead of using a network server to keep on copying this, we kept a secondary name node which kept the image and edit log. And whenever name node fails, we bring the secondary name node up by combining the image by kind of imposing the edit logs on the namespace image, and then secondary name node would contain the latest data, and and then we'll run that as a system. That will be our new name node. Okay, so the only downside of this kind of arrangement is the secondary name node needs to be brought up manually. It's a backup, not a failover. It's a backup, not a failover, because there's a manual intervention required in order to bring it up. So people were not happy with this kind of arrangements. So that's where the idea of a name node standby came into play in Hadoop 2.x. Okay, in Hadoop 2.x, as in after 2.0, the idea of standby came into play, and it's a very important idea, and it's used in a production environment. We are about to set up the standby in our CloudX lab as well. Now, in case of standby, we have many data nodes, and I mean many data nodes talking to name node as well as standby. Okay, so the way every data node was also informing name node about every change, every data node was also informed about standby. So standby receives information from the name node, from the data nodes, and so on. So any change which name node does, it also sends a copy of that change to standby, and standby applies to it. And all the data node, when they confirm something to name node, they also confirm the same thing to standby. Effectively, standby tries as much as possible to keep the data fresh. And also, since it's better to it's better for it's better to keep as much as less load on name node. Therefore, data nodes are also programmed to inform standby. Now, question is that how does the failover between name node and standby happen? Who will do the failover? How exactly does it happen? So the way it happens is between the two there is a kind of information board, or you can say whiteboard, or a notice board called Zookeeper. Zookeeper contains the name of the current name node. Okay, in case name node goes down, that name which was written at Zookeeper automatically is washed out, and only the standby would remain at Zookeeper. So Zookeeper will contain, and we will dictate or will display to the end user that who is the current name node. If a name node goes down, the control switches to the standby. If the old name node comes back, the old name node will be the new standby, and the previous standby will continue to be the name node. Okay, so Zookeeper keeps on shuffling between the two. Okay, we will go into the details of how does Zookeeper do it, but in simple words, Zookeeper is more like a file system which contains many different kind of folders or files, right? There is one file called temporary which disappear as soon as the connection breaks, and that's how the name of name node will be removed from Zookeeper as soon as name node is dead. Okay, now the client library consults Zookeeper that hey, you are somebody who knows about both. Can you tell me who is up and who is down? So Zookeeper will say, okay, this guy is current standby, talk to him. And Zookeeper is not only for HDFS, Zookeeper is used by almost everybody for this kind of coordination. Okay, Zookeeper is something which is used a lot in case of coordination. So you as an end user talk to the client library talk to the zookeeper keeps on shuffling. I mean, automatically the shuffling happens between the name node and standby based on who is up and who is down, and then the communication between the standby keeps on happening. Okay, so this is a kind of a symmetric behavior of name node and standby. Both name node and standby are identical to each other. Their memory, the RAM and everything is supposed to be similar, and so on. Now, question to from Akshata is, can Zookeeper go down? Yes, Zookeeper can go down, but the beauty of Zookeeper you will realize when we discuss in detail, and this is exactly the reason why we discuss Zookeeper. Because Zookeeper is not a single machine, it's an ensemble or a group of machines which run Zookeeper. Although the word Zookeeper is singular, but inside there are many machines. Okay, we will see and look at it how Zookeeper does all of that. A question from Anuj is, oh, okay, I think I missed a question from Tracy as well. Okay, before that, I missed quite a few questions. All right, good, very good set of questions. Let me not skip these questions. These are very good questions. Okay, brilliant. So here we go. All right, so this we have answered. Now, next question is from Akshata. This takes care of data on name node, right? But if name node goes down, who acts as a backup to take up the function of name node, right? So we'll have to, in case of a secondary node, we will have to start the another secondary node and recover the data. But the same has been replaced very well with standby. Samip's question is namespace image like metadata? Yes, namespace image is the most recent snapshot of the metadata. But since metadata could be huge and therefore taking the snapshot could be tough, therefore edit logs are kept. So namespace image would be little older than the metadata. Okay, if you superimpose the edit log on namespace image, it'll be like the current metadata. Now, Ravichandran's question is, name node and secondary name node would be in two different locations, right? Yes. The copy of namespace image and metadata are kept over two different locations. Otherwise, the purpose of keeping the backup is totally defeated. Very good. Tracy's point is that MapR has multiple name nodes and does the failover automatically. They use the similar architecture what we are talking just now. Okay, Josephine, was I able to answer your question related to Zookeeper? We will go into more details when we go into the Zookeeper. So, all right, great, great. Now, a question from Akshata is there a limit on how many name nodes are allowed, as it is an overhead for data nodes to inform all name nodes. So generally, we don't keep too many name nodes. Generally, we keep like two name nodes, as in one standby and one name node, but you can have more. and Zookeeper can shuffle between them. But a clever thing would be to have only two or maybe three name nodes. Good question. Yes. So I think I've answered Akshata's question regarding Zookeeper Go Down. Can we use to share the load as well on name node during peak time? The quick answer is no. All right. Quick answer is no. Otherwise, the moment we say the share the load, right? What would happen is that there would be two ways to get into the file system, and effectively the consistency will be lost. So so most of the heavyweight lifting of transferring data is done by data node. So name node is not generally consulted, and the communication between with name node and the driver is kept as much as low as possible. Okay. And if we start, modifying some file through standby, modifying some file through name node, what would happen is that if the inconsistencies will start. Even let's say we are keeping one file system for reading, other for writing, still there are chances of inconsistency, because let's say a file is being rewritten by modified by one client, and there is some time delay between writing and reflecting. Therefore, somebody who is reading the file at the same time would read the older data while there is a new data available as of now. Good. Very great questions. Very great set of questions. All right. Yes, Anuj, I'm also happy to be instructor, because instructor of a group that won't let me take a breath. Okay, because if you don't ask a question, I always feel that you did not understand, and I'm really a bad teacher if people are not asking questions. All right. So yeah, I love to provoke the questions, and I love to promote the questions, because that's probably the single way of learning anything. That's the only way to learn anything, by questioning it. And that's why we go into the detail, like why we are not using that particular design which we were using 10 years ago. A question from Narottam. Zookeeper also does the request distribution to primary and standby name node to do the load balancing. Zookeeper also does the request distribution to primary and no, it doesn't. So Zookeeper is like a whiteboard. The only problem with this whiteboard is that name keeps on disappearing as it becomes old. Okay, so you can think of this whiteboard as where the name automatically fades after a period of time. So name node and secondary name node and standby both keep on writing their names on this whiteboard. Whosoever dies, their name won't be there in Zookeeper after a point of time and would be considered dead. In the same way, Zookeeper, the name nodes also discovers data node using the Zookeeper in the same exact way. All right. So good. Very great set of questions. I thoroughly enjoy such class. All right. Now, Akash's question is there a limit to access name node at a particular point of time? If yes, can it be extended? Good question. So if there is a name node and there are many people accessing the name node, what would happen is it would queue the requests. It would queue the requests in a single queue, and then we'll start catering to the request in a parallel fashion or a similar fashion. So the way it does is it does the queuing very cleverly, so that if two people are trying to access two different files, it doesn't block them. But if there are two users who are trying to access the same file, it'll keep them in queue one after another. All right, does it make sense to you, Akash? All right, brilliant. Now, the next question is, yeah. So next question is HDFS Federation. All right. So Prithvi's question is why to put them in a queue, instead let them access the other replicated data. So yes, good point, Prithvi. The only problem is that when, let's say, there is a the same file being modified by one particular thread or one particular client, it doesn't make sense for other people to access the file in parallel, because it might result in total inconsistency. All right, that's why if there are requests for the same file, they are generally queued together. And that whole queuing mechanism is fairly interesting and complex, because if all of them are read request, then it will let them go. If there is one write request, it will let it wait before all the requests finish, and then it'll let them modify. All right, do it make sense to you? Brilliant. Okay, let me explain mount tables, Kanan. All right. All right. So what we understand so far is that name node contains metadata. If there are too many files, they will have too much metadata, because every file will have a folder name and access name, block, block ID, and everything. So every file would result in a decent amount of metadata. If there are many more files, let's say, even if the file is of 1 kilobyte, still it's going to consume, although it's not going to consume the much data from the data stores, but it is going to consume a lot of metadata store, right? Which means if there are too many files, name node might get busy, RAM could get full at name node, and this mechanism therefore name node would be limited with respect to number of files, right? Because so So it's not the size of the file which concerns name node. It is the number of files, total files, that concerns name node. All right. So in situations where you really cannot accommodate so many files in name node, okay, in a single name node, what in those circumstances you could have two name nodes, name node catering to one folder structure and another name node catering to another folder structure. But the beauty of this architecture is that they are going to use data nodes from the same pool. Meaning, same set of data nodes are used to store their blocks. Okay, so data node act as actual physical blocks of data, and their name node contains pointer to those blocks. So you could have two name nodes in these kind of situations, where we call it HDFS federation. Why do we need HDFS federation? When we cannot go beyond, when we when our name node's memory is full and we want more files to be stored, and we cannot increase the memory of the name node. So in those cases, we create something called mount tables. Mount tables are basically stored on the client side. On the client side, while configuring HDFS, we hardwire it. We say that All the requests in which we are modifying files under these folders would go to name node 1, and all the folder requests or folder modification requests for the second, say my data 3 or my data 2, would go to name node. So mount tables would direct. So client library, while making a request for modification of a file or reading a file, first check in the local configuration of mount tables and talk to the name node. Okay, and that's how it is managed. It's as if two separate name node systems storing data on the same data nodes. Okay, so it's like this. So HDFS federation is useful only when your number of files are too many. But that's not the right way to do things generally in HDFS. In HDFS, what we do is if we have to store too many files, we generally combine them together in tar format or RC file format and then store them in HDFS. We will discuss these things in more details. So instead of storing too many files, imagine that you are LinkedIn and you have to store everybody's profile picture, and there are say 100 million users on your servers. So if you have 100 million users and there are 100 million photographs, and every photograph is a single file, say single kilobyte, let's say 10 kilobytes. So let's do some math. So if you see, let me just open the calculator. So if you have say 100 million users, 1 2 3 4 5 6, these many users for LinkedIn, and everybody is using say 10 kilobyte. So these many kilobytes are is the total data, right? And 100 million files are there in total, right? So if you store 100 million file, it's going to consume the data, metadata really high, while the data node will be consumed in the same manner. But if you compress this data and make it a single file, right? If you compress this and make it a single file, what happens is that this kilobyte of data would be divided into how much? Let me convert it to this much megabyte, right? Divide by 128. So only 7,629 blocks, right? So earlier it was consuming a data equal to 100 million blocks. Now it's going to consume metadata only equal to 7,500. Therefore, a general practice is that we combine all these files and create a single file. And generally, there is a standard format that we go with in HDFS called RC file format. We will talk about RC file format later on. Okay. There is a purpose why we kept it RC file, and we will discuss it later. Because that reduces our hassle of combining the data. And we are not compressing the data, we are just concatenating the data. Okay. So generally, instead of having too many files, we try to combine very small files into a big jar file or tar file or RC file, and then we use that, we store that. So this kind of scenario would be really, really rare. Okay, a very good question from Ajay. Is there a support to mount HDFS as other native file system? Yes, it does. You can use simply mount, and we have installed something called mount, what do you call, mount bridges, using which you can mount HDFS as if it's a folder. And whenever you put a file into that folder, request goes to name node internally, and the whole magic happens. While for you, it's just a file system. Okay. A question from Samip: why not secondary name node in this scenario? Good. Secondary name node does not solve the problem of distributing workload. This actually divides the workload. Okay. Anu's question is, what will be stored in name node? So there are two name nodes, each name node taking care of their own folders. Okay. All right. Just details for RC file or information about every node. So i- when we have converted the whole file into a tar or RC file or jar or whatever you want to call it, or zip file, we've basically concatenated all small files into a single big file. So name node will contain the information about this file. Okay, about this big file, the blocks belong to this big file, right? So when you do this, what would happen is a single image, even though 10 kilobyte, half of that image could be on one data node and half of the image could be on another data node. We will discuss how we tackle this kind of sharding, right? So it's like having a big box and packing the cheese in small pieces of cheese into a big box and then cutting that big box into another sections. So Anu says that who knows the information about which image is in which node? Nobody. Okay, so anybody who wants to figure that out first reads first kilobyte of the file only from the first block, and that's it. It just finds out which blocks would might contain this data based on the offset. So that's a completely different philosophy. So RC file is used exactly for the same scenario because it's easier to predict where is which file. All right. So here what we see is my data one, all the files related to this folder will go to name node. All the information related to these folders would go here. And in case there's some other folder here, that will be ignored. All right. Now, this secondary block, this is secondary, what do you say, standby, not secondary, it's a standby. So every name node could have their own standbys. So you have here essentially four name node. These are two uh, which are mirror of each other. These two are mirror of each other, and they and this one these are having the same their data blocks in the same nodes. All right, good, very great. Is that what, Josephine, your question was regarding what's in the subfolders? Okay. Now, a question from Anuj. But we are saying pack 1,000 kinds of cheese, put it in a block, and divide the big box into big blocks, small blocks, as in 128 MB. Okay, so in this case, the first block of the big file, this big file containing all small images, first block of this big file would contain the information about the header of the file, and this header would tell us that where is which image. So RC file contains this information in the header that which section of the data is how far from the beginning. Do I make sense to you, Pavan and Narottam? Okay, so the mount tables are basically configured. So when you configure your HDFS to handle the federation, so you create a config file which contains information about if a request is about this folder, go to name node 1. if requested about this folder, go to name node 2 and so on. If Okay, so if the request is about these folders, go to these nodes, and this config file, okay, this config file is not this mount is called mount tables. All right, so client library reads this config file called mount tables and then finds out that if we want to request this particular folder, where to go, whether to go to name node or to go to name node 2. Okay, so client library deciphers this relationship between which folder is where. So this is basically a static mapping. Mount tables is kind of a static mapping. It doesn't change so easily. Subham's question is, if there are too many read operations for single file, does the replication factor automatically increases at runtime as default is 3? Very good question, Shubham. So there are layers of client drivers. You could program your own client driver, and that's actually fairly tricky because client driver a read request might lead to one read and one write. Okay, so there are third-party system like Qbol has a layer on top of HDFS, whereby when somebody accesses a file, it automatically increases its availability. Anuj's question is, so is like client request name node? Okay, was he able to answer Subham's question? Okay, question from Anuj is, so, client request name node reads RC file header, RC file tells in which block a particular image is, the name node has information about. No. So the moment you pack all the files into a single file, you are at your own. Name node does not care what's inside the file. Okay? Name node doesn't care what's inside the file. And creating RC file is more or is only good if your data is not changing very frequently. If you have many small files and you want to modify them, probably an H-based kind of model will do a good job. We'll discuss that again. Patrick's question is, where is the mount table stored and who maintains it? Mount table is generally stored on all the nodes which have the Hadoop client library. And the duty of maintaining the this mount table is on everyone who is having the client library. All right? Do I make sense to you, Patrick? Although it's kind of a hacky solution that in case somebody modifies say mount tables and says no, for my data too in my configuration file we have mapped to name node 1. Okay, so name node 1 will essentially say that sorry, the folder is not found. Okay, so this is basically a client, this is basically a configuration. It's not a service that's running, because if there is a service that's running as mount table, then that will become the bottleneck. Do I make sense to you, Patrick? Yes, that's right, Patrick. Everybody maintaining the mount tables, that includes data node. But good news is that you don't have to take care of it. The systems like Ambari will push these changes to the mount tables to all the nodes. All right. So the copy of mount table, the file which contains this mapping between the actual folder and the name node, is capped on wherever there is a client library. Client library is basically an offline library. It is not a central server. All right. Good. Great set of questions. And it's a genuine question because in the beginning I also thought that's actually very strange. But then I tried to dig it a little bit and found out that it's basically to avoid somebody becoming the bottleneck. Instead, let there be one copy of mount table across the cluster. Good. Very great. All right. So this was the federation. All right, so this we have already discussed. The metadata is essentially entire metadata in the memory. There is an on-demand paging of as well as periodic uh, paging. Paging means converting the metadata into the namespace image. Okay, basically persisting the copy or mirroring the copy of metadata into the disk. Okay, so there are types of metadata. I mean, what does metadata contains? Metadata contains number of files, folder structure, and list of blocks of each file, list of data node for each block because there will be replication, and then for every file the attributes such as access time, replication factor, file size, file name, directory name. And there's going to be transaction log which records file creations, deletions, and the details of everything. All right, so this file system is good if you have append only structure. HDFS is great if you have only append only. But if you try to modify a file, if you try to modify an existing file, it's equal to creating a fresh new file. Okay? Therefore, the client driver does not provide you functionality of modifying a file. Even if you are modifying one single bit of information in the file, it's equal to creating a new file. But having said that, HDFS provides you a way of continuously appending a file because continuously appending essentially does not touch the existing data nodes. Instead, it adds new data nodes or blocks. All right. Okay. So here is a question which somebody has asked earlier. So if there is a file located in the HDFS, to find out where is it, you can use as HDFS FSCK and blocks and locations. I'll show you. So let me open my console. All right. So I will, before I get into more details, I think let me just see what else is left. Good. I think it's the time when we discuss how to upload data and how to access data. Okay? All right. All right. So here we go. Also, for those who quickly want to get access to CloudX Lab, if you go to CloudX Lab directly and click on My Lab, you will get the details. You'll get all the details here. All right. So you can get like lab credentials, MySQL credentials, IP mappings. What does it mean by a CloudX lab? Because there is a local IP of every machine and public IP. And then also there are few videos which we have put there. So you can take a look at those. All right. And there's another session on June 15 coming up, which you can register for. All right. Now, coming back to here, let me go to Web Console. All right. Let me log in. Okay. Now, that's my console, and let me open Hue as well. Oh, it's already logged in. Great. Okay, so here we talked about quiz presentations. The slides, whatever we are discussing, is available here as well. The installation instruction go through two kinds of things. One, installing downloading a virtual machine which contains Hadoop and installing, but that's not required because we already have our CloudX Lab. And and then installation on cluster. Then the discussion notes of the previous session. This is the recording of the previous session. Also, there is a session on regular expression presentation as well as regular expression session, because whenever you want to churn data, make sure that you learn regular expression. It's very important. Since after I started my class and I realized that there were only few people uh, aware of regular expressions. I had created this regular expression session. Also, you would be having this Java sessions. Go through the Java. That is going to be quite useful to all of you. Now, coming to the second session called HDFS and MapReduce. There is the presentation. The quiz is same as the session one. Some of the questions in the session are related to HDFS. Then you have example of CloudX Lab. Sorry, here the file systems explained. Okay, so it's not CloudX Lab explained, it's a file system. Now here there is, okay, not this. Okay, just a second, let me go through. All right, there are few here. You can see the Linux cheat sheet whereby you learn at least those basic commands. Those will be quite useful. And I'm still trying to find out. I'm still trying to find out. Okay, no worries. Let me make a note. All right. The hands-on sessions. Good. So what we are going to do is because we had created these hands-on exercises for everyone, and that was the previous session. Yeah, there's a hands-on guide. For now, let me just send it to you over this chat. Okay. Let's before it gets updated in the new session. So there is a hands-on guide. Okay, just go through. I mean, that's very important to go through that guide. Okay, all right, all right. So this should be good enough for you. So this hands-on guide, which I've just shared, I will also make a note of it here. And this is my hands-on guide. All right, now, so this hands-on guide, which we talk about here, goes through the various tasks that you can do. Okay, you can log in, you can go to file browser, you can upload files, you can do all of these. So make sure that you do follow this hands-on guide and do whatever has been suggested in there. I will show you the same thing in the console right now. So here, when you log in into Hue, this is the file system of this is a file system of HDFS. This is in the HDFS. You see, slash is top level, as in you can't go above slash. Under slash, you have user, and there are some more folders. One folder is called data. This data would be used over the course as we go forward. Okay, and there are other folders like apps. In this, HBase is storing its data. Okay, you remember our discussion on the last time that HBase stores its data in HDFS. So here is the data being stored by these applications inside HDFS. All right, now as a quick test, you can see if I click on home, here we have these files, but these files are not there if I log in into console and say ls. Do you see big data in Hadoop 7 a.m.? No, right? It's not there here because this file system is not HDFS. This is local machine called e.cloudxlab. It is one of the nodes in which we are logged in, right? It is one of the machines on which we are standing right now. So we have three things. My laptop. So we have three things. I'll just pick up that diagram. Yeah. So we have three things. One, my desktop, or this is my desktop. This might be your desktop. And you have A, B, and C. These are the various nodes of the cluster, right? Here I'm calling it Hadoop 1, Hadoop 2, Hadoop 3. In our case, it's, you can see D, and this is E, and there are A, B, and C containing various data nodes. Okay, so these are also machines. Okay, they are also machines too. So from your desktop, if you want to directly upload files in HDFS, you use Hue. That's what it shows. From your desktop, if you want to directly upload data to HDFS, you can use Hue. So I can say delete this data. Let me just delete. Good. And then upload files. Okay, I'm trying to upload data. Let's say I have some download folder here, and I'm trying to upload, let's say, um, let's say, is there a nice file which I can upload? Something which is a little meaningful as well, not like bank statement. Okay, never mind. So I'll just upload today's notes. Let me first save these notes for today. I'm saying notes for 5 June. I've saved it, and then I'm basically going to the folder in here. Where did I save it? Okay. All right. So this file has been uploaded into my HDFS. What's the name of the file? It's called notes. It would be on another page, so I can search here quickly, but remember to remove this, otherwise you'll get confused. So this file has been uploaded successfully. It's called notes 5 June in my home folder called /user and /this. But if I see here, it's not there. It's not there. If I say ls is for listing files in the home directory. So let me just make it a little clean. Okay, so do you see any file? No, there is no file starting with ano. Good. Now, to interact with HDFS, we use a command called Hadoop fs, and you can see. All right, so using Hadoop FS, we could talk to HDFS, and from the command prompt, you can see that these are the various commands various commands that we can use on HDFS. We can append to an HDFS file. You can concatenate, you can print the data in an HDFS file. Then you can change the ownership, change the mod, as in change the mode of that file, who can access and who not, change the owners, copy the data from there to local, copy the data from this local machine onto HDFS, copy the data from HDFS to the local machine. So we are going to use first cat, then copy to local. All right. So we are going to say Hadoop fs minus ls and node. So let's see if there is any file with this name. Nice. We have this file there. I'm using Hadoop fs minus ls. Now let's check if it contains something. You can see that it contains all the records that we have put in, all the notes for today, right? Now, if I want to, the cat is just printing the data, bringing the data from HDFS. Now, I want to do is I want to copy the data to local. Local means to this machine called e.cloudxlab. This is e.cloudxlab. Okay, this is e.cloudxlab. Now I'm saying here that copy Hadoop FS copy to local, meaning bring data from HDFS to my local machine. Okay, now you can see that it has come here. To see what's there in it, you could either do cat or use an editor. It's a text editor called Nano, which we have installed there, using which we can modify this data. Okay, we can say modified data and save. Let's say we want to rename this file and call it _1. Move this. In Unix, to rename a file, we use this command called move. So we used ls, then cat, then copy to local, and then we modified the file locally, renamed it, and now we are putting the data back from local file system, meaning the file system on this machine on which we are logged in. We are saying copy from local. Okay. Now, where will it copy? It'll copy in my home folder. Okay, let's go back to HDFS and check. You see, there are two files now, and the second file is here. We can do the same thing. We can happily remove our local file, and also we could check Hadoop fs minus ls. It's basically the same thing as using this browser. Okay, we could say node star and it'll show us two files this time. Alright, so that's pretty much for today. Please go through this hands-on document which I have shared with you. Alright, if you have any doubts, please schedule a one-on-one with me so that we can discuss in detail. Alright, what's the difference between cat command versus VI editor? So you can use a VI editor is, gives you the flexibility of modifying a file, but cat only prints the data. Okay, if I say cat notes, say, let me again copy the data. All right, copy to local. We have to say copy to local. Okay. All right. So VI is an editor. It can modify the file while cat can just print the data. Nano is another comparator of VI. Probably you meant by VI. Okay, you just send me an email with three different times so that I can schedule a one-on-one accordingly. Okay, just send an email suggesting three different time slots. Okay, Since I live in IST, okay, so and I wake up quite early, so you can schedule anywhere between 7 a.m. to evening, say 8 or 9 p.m. All right. So I'm saying 8 a.m., say 7 a.m. to say 9 or say 10 p.m. IST. Okay. Just suggest me your one-on-one good time, and that'll be good. All right. So in case you get stuck, but I would strongly recommend that you go through this hands-on guide and you go through this file system explained. This. Yes, hands-on and the quiz is the assignment. Please go through it. All right. Great. So thank you very much. And if you have any questions, feel free to send us an email at reachus@novicdata. All right. Bye bye. Have a good day. Thank you. Thank you for a great class. I'm totally enjoying your questions. Keep the questions coming. So CloudX Lab, you can see your details. It should be up to the I think it would be up to this date. It says the lab access. This is not correct. No, this is for 9th April class. This is not for you. This is the one. It's up to July 17th for you. Not this. Sorry. July 31st. All right. Thank you, everyone. Bye bye.